This conference will now be recorded.
All right, so in here they're gonna go through um IPv4, IPv4, and IPv6. And as you can see, they got one quiz and then some guided exercises and then a lab. I'm not gonna teach everything directly from here. I'm gonna point out things that you're gonna need just in the future outside of Red Hat. Outside of Linux, they're just gonna go with you if you do networking, if you do your A plus or anything of that nature, or even if you're just doing interviews. All right. So right here, they talk about the TCP IP model. Um, and my best thing to tell you is memorize this page for any type of interview. This OSI model, the 7-layer OSI model, is going to come up. It always does. And understanding the difference between TCP and UDP. So let's go here first. All right, and let's look at some images. So you can, this is the one that's always sticks out of my head right here. All right, so with the TCP IP model, what you see here is, and this is how you are running on the on your home device now. You're sending out TCP packets, right? And TCP is secure and UDP is not secure, right? And what you'll find the difference is this. With UDP, you just, and this is how DHCP works. There is a component of TCP inside of UDP that no one really talks about. So it can go both ways, but primarily DHCP is a UDP. It uses UDP. In other words, it broadcasts across the whole network, right? So it sends out broadcast traffic across the network and hope somebody answers, right? It's just like you got a wall, and you just got like 50 different things, and you hope one of them sticks. So you just throwing stuff out and hope it sticks. That's what you see with, and you can see this if you use Wireshark or something like that. You see UDP packets going out and TCP packets, but you'll get a chance to see how UDP packets really work, right? So with TCP, you can see there's a stage, right? I'm gonna send something out, and then somebody has to acknowledge that they received that send that back, and then acknowledge that send back, right? So really, it comes like really down to uh, 3 steps: send, acknowledge, and then acknowledge that. Whereas UDP, you're just throwing it out there, push it out there, and then hopefully you get a response. And that's primarily what you'll see with people ask you about TCP and UDP. And so I'm going to give you this so you can just have that. Now, oh, I can't paste. I don't know why. I'll give it to D. Hold on 1 second. I'll post it in the RC study group. That's what I'll do. I'll post that link in there. All right. So let me go to the study group, and I'll post this link. All right. So in here, they talk about, why do you not go? Wait, there we go. Okay, in here they talk about TCP offers flow control mechanisms. So, with TCP, you can say I have a between two hosts to two IP addresses, I want to send TCP traffic, right? And really, it's again TCP ensures, like they say here, and it ensures reliability end-to-end delivery, resequencing and retransmitting of data until a timeout is reached or acknowledgement of data packets is received. And they talk about different protocols that are TCP, FTP, HTTP, HTTPS, SMTP. Then they talk about UDP being a connectionless. There's a connection protocol and then a connectionless protocol, and they talk about over the transport layer, and we'll talk about that. And so they talk about since UDP protocol is simple protocol, the retransmissions of packets can be decided at the sender's end, whether to trade low latency for higher reliability over data transmission. UDP reduces overall network traffic owing to the network broadcast. See, that's what I was saying here. It's just sending out a broadcast of, hey, you there? You there? Will somebody answer me, please? You there? That's what DHCP does. It's just constantly just sending out like over so many seconds, like, hey, I'm gonna keep trying to broadcast across the network until I get an answer. And that's what you get with UDP. Right. And then they talk about in here how it works again. And you don't have to worry about this header size and so forth and so on. Let's go back to the class here where they got, okay, the TCP model. Okay, where does TCP and UDP work? It works at the transport layer of the OSI model and the transport layer of the TCP IP model, right? And then as far as application, presentation, and session, they tell you which protocols and services work at that level. Network, when we're talking about, hey, I need to ping someone, you're pinging someone across the network. And then this right here, data link and physical layer. This is usually your switches, and then this is your physical ports, your physical interface, your physical things that you can touch. This is your Ethernet right here, and this is how the two relate to each other. There's actual, I don't want to call it an acronym, but there's a saying on how to memorize this. I just have it memorized because it's been ingrained in my head for 20 years. Same way with this one here. So then they come into describing the different interfaces. I won't go through all of this right now. I just point out some highlights and you can read through this. This is just, I'm overviewing this first and then you go read it. So in the old days, and you'll find this inside of you'll find this inside of most clouds, the naming schema of how the interfaces were named changed. Now they're like ENS 192, 189 or something like that. But for the cloud services, there is a way to mask that, and you can now name it. You'll name them ETH0 and ETH1, and you'll see that if I bring this up here, you'll see if I do a IF config, you'll see that my interface is named ETH0. On a default install from Red Hat, it won't be named ETH0, it'll be named ENS 192 or something like that. That's the new naming convention that they use now, right? So they say the network interface type, they say the newer versions of the Linux system use a different naming system. Instead of being used based on detection order, the names of the network interface are assigned based on the information from the firmware, the PCI topology, and the type of network device. So ENWL for your wireless LAN, and then WWWAN. That's how they all start. So like I said, it'll say ENS or EN whatever. And then they go on to talk about PCI and so forth. Now we get into IPv4 networking, right? And now we're getting into how to basically subnet. So I'm gonna show you a different way for subnetting, but let's look at this here. Oh, not there. This here. So I have an IP address of 10.128.15.227. My net mask has all the bits on. And when I say all the bits on, each octet here, each one of these octet, when you turn on all these bits here, this is when we're start talking about, should I be a /16, should I be a /8, should I be a /32. Each one of these octets represent 8 bits, right? So 8 bits here, 8 bits here, 8 bits here, 8 bits here. That gives us 32. Here they have a /16, so that means that these bits are on for my subnet mask to be 255, 255. So if my subnet mask is 255, 255, 255, 255, that means it's 8 bits here, 8 bits here, 8 bits here, 8 bits here. That means that's a 32-bit subnet mask, which means this is more than likely my IP address, right? 10.128.15.227. If it was 10.128.1, and you had 255, 255, 255, that means this right here would be 8 plus 8 plus 8. So it'll be a /24 subnet mask. All right. This is how you are doing subnet mask. Here they're showing you the binary way. So basically, what they did is say, well, what is 172 in binary? What is 17 in binary? What is 5 in binary? And what is 3 in binary? And then they come down here and they say, well, if you have a /16 right here that we see right here, that means we're going to have all these bits on, all these bits on, and these bits will be 0. And so what they do now is basically they do what they call an ANDing process, is they add these two together. So this gets into binary. So let me go over here and pull this up for you. All right. So how to AND binary. Let's see if they got a image. So we can do this really easily. I'm looking for something. All right. This is probably going to be one of the better ones here. So you can understand how they came up with the 255. All right. So they came up with the 255 by saying, okay, well, in this first place is 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh. And when you take all those and you add them up, that's going to equal to 255. So all these bits are on. So if we didn't have all these bits on right here, if these were all zeros, you would add up 2 to the second, 2 to the first, and 2 to the 0. So 2 to the second is 4, 2 to the first is 2, and 2 to the 0 is 1, right? And you add that all up, and that would be this number here, if all of these were 0, right? So that's how they come up with the number. So then they give you an example of this. An example would be, okay, we got 2 to the 7, 2 to the 6, and so forth, but what's turned on? Well, 0 is turned on, 2 to the 0 is turned on, 2 to the second is turned on, 2 to the fourth is turned on, and 2 to the 7 is turned on. So you add these numbers up. They didn't put that number right there, but that's 4. So that's how they end up with the 149. And so back over here, when we're looking at this, you should be replacing this field with like 2 to the 0, 2 to the first, 2 to the second, 2 to the third, so forth and so on. So now let's talk about an AND. Or did they do an OR? They had to do an AND. Yeah, they had to do an AND on that. Yeah, yeah. All right. So let's look at the and of this. So basically, what they're saying is, if you want to know how many networks you can get out of this subnet mask, you need to do an anding on the first two, octets, and then on the last two octets, will give you your host. I'm going to show you a different way, but this is the first way, and this is time consuming to me. All right. So with that being said, when I say an and, meaning that one, one and one will give you one. So in other words, you have to have a true statement. So one and one will give you one, right? So that's what they're doing there. And that's why I was a little thrown off with this one here, because um, one and zero gives you zero, and here they got one and zero, and they getting a one. That's why I'm confused. That unless they don't end it, they're just bringing it down, and they're only ending this. That's what that is. They brought this piece down. Yep. So they was like, it's zeros there, so ain't nothing that it's nothing to end. Just bring it down, and that's gonna give you the number of hosts. And then because these octets are turned on, we got the ones here and those. So one and one is one, zero and one is zero. One and one is one. And so where I'm getting that from is simple logic. Logic is called a logical and this is how they taught me inside of my Cisco class. And then you just have to use the truth table here. Basically, that's what it is. So as you can see here, zero and zero gives you zero. Zero and one gives you a zero. One and zero give you a zero. And one gives you a one. So this is the logical and we were here. So let's go back over to our page here where I said one and one give you one, zero and one give you zero, one and one give you one. So basically everything where there's a one up here and a one right here is going to give you one, right? If it's zero and zero, just humor me for right now. If it's zero and zero, give you zero, right? So that's what they're saying here, right? And that right there is the long way of doing this, right? Because you're not gonna have time to write all this out and do this. So let's do this another way. Any questions so far? All right. So this is what they do here. They give you the host address, and they take it and they turn it into binary. And then they say you got a slash 24. Remember, each octet is eight. Each octet is 8 bits. So if it's 24, this is on, this is on, this is on. That's off. Altogether, it would be 32. So then they take this and they do. Looks like they did like a network address. They want to tell you what that network address is. So one and zero will give you zero. One and zero will give you zero. So yeah, it looks like they ended this part, and then they give you the broadcast of that. Yeah, way too much for me, right? So let's go. Let me see if I can find the easier way. And the easier way would be, hey, here is a slash 24 subnet mask. How many bits are left over, and then how many bits are used. So this is just another way to get do subnetting, and that's what we're doing actually. So subnetting. All right, let me see if I can find a good cheat sheet. Let me see what they got on here. I hope they're not doing the ending process. Class A, Class B, Class C. network mask. Yeah, it looks like the and. Yeah, I don't want to do that. I have to look it up. It'll come back to me. It's been a long time since I did it. And then it's variable length subnet mask VLSM. We won't. I don't think you need to do that on here. You may need to do that in AWS or something like that. But let me come back to it. Let me think on it a minute. Because you put in how many networks you have. I mean, you put in, you do 256 minus what you have, and that should give you calculating first usable subnet. Let me see. And I always have to remind myself on how to do this. Let's see. It's supposed to be a PDF. Let's see. Mm-hmm. We're requiring on the base design, blah, blah, blah. Oh, yeah. All right. The number of bits borrowed, the number of host bits borrowed is 14. The number of host bits remaining, that's what it is. All right. This is the easier way. And let me give you this. I'll post it in the chat if I can. Nope. I'll post this inside of the Slack group. Okay. So when they're talking about the bits borrowed, this right here, this 255, 255, 224, those are bits borrowed, right? So those are the number of bits that you borrowed. So you can calculate the number of bits borrowed, and they tell you right here with a /19. What this is telling you is the number of bits, number of host bits borrowed, then the number of available, and the number of bits borrowed, and then the number of bits left over. So the number of bits borrowed for us was, in that case, was 20. Hold on, let me look at the range. Hold on, 19. Where am I at? It's 172 Class C. So they were saying that since it's is that a Class C or Class B? I mean Class B. Let me get my order right. 16 minus, that's wrong. I think it's 24 number of hosts, bits borrowed, number of hosts, possible hosts, and then the subnet mask. /22/23. Let me go through this. All right, so the number of bits borrowed, we know is 19 because we got that from here. We added that up with that. I think the bits borrowed give you the number of hosts, and the bits left give you the number of networks that you can have. And you subtract that from the 256, if I remember that correctly. I may be wrong. I may have to go through this and work it out. Yep, because here it is right here. So example of a class of IP space are shown in the table. The number of bits available, in other words, what's left over. And you can get that from here. So you got 8 bits left in, well, more than 8 bits because you got 255. So you got 1, 2, 3, 4, 5, and 8 and 5 is 13. So you got 13 bits left. So they're saying here the number of bits left, you're gonna end up subtracting that out from 250. Is it from 256? Yeah. And then the number of hosts that you can get off of that network. I'm gonna have to go back through it so you all can see the easier way. Because this way that they got in there is very long. I don't see you doing that. So give me a minute. Let me think on it if I can get it right, and we'll do that. And then in here they talk about, and this is what they don't talk about in here that I didn't see, is recognizing a couple of things. One is if this is a private IP or a public IP. So we have some private IPs that are called RFC IPs. And those private IPs, let me see on the private network, they probably come up right here. Usually are your 10 IP addresses, your 172 IP addresses, and 192 IP addresses. Where does this show up at? It shows up when you're doing routing inside of AWS and GCP. So reserved IPs in AWS. So they'll have a set of reserved IPs in AWS, and you probably do the same thing in GCP and so forth. But they'll say that these right here are reserved, and they walk you through that, that these are reserved. And little FYI about the range of IPs. Some IP spaces are owned by the military. Some IP spaces are owned by different entities. Let me, yep. All right, so they'll have like, see right here, like AT&T owns certain ones, and I don't know if this is still true for Apple. They might have dropped this and moved and expanded, but certain entities used to own, different IP spaces and so forth. So you weren't allowed to use those IPs. So and then that's where IPv6 came into play. They were like, hey, we're running out of IP spaces. We need to move over to IPv6. So that's what that is. And now when we start talking about IPv4, you can see here where we have a default gateway router. We have two networks or two interfaces attached to it. We have a private network on the 192 side, right? And they give you the network ID for this 192.168.5 with a /24, meaning this octet, and this octet are all on. This last octet is not on, meaning that I can start. I'll get 254. I'll get 254 hosts on this network. And then my first and my last are not usable because my first needs to be reserved and my last needs to be reserved for broadcasting. Right. So 9 times out of 10, the broadcast on this network is 192.168.5.255. When I want to broadcast out, like if I wanted to broadcast DHCP across this. All right. So we got 192.168.5.254, not 255. And then 192.168.5.3. Remember, the first three octets are on. It tells me so here. It tells me so with this /24. And it tells me that my network is that everything up to that last octet. So all of this will be my network there. Here, this tells me I have a /16, which means the first two octets are all on. All ones in the first two octets, and then these two octets are open. So that's why you see I have a 172.17.77.6 and then a 172.17.53.1, meaning I can use these two octets right here to create me some networks and some hosts. That's what we're doing there, right? So we know that we have 32 bits left. We know we have a total of 32 bits, right? And we know we have 8 bits left, right? So it goes, 2 to the 8th. Can I do that here? BC. 2 to the 8th. Can I do that? Yep. That gives me my 256 minus 2. That gives me 254 hosts. I knew it had to come back to me. I borrowed 3 I borrowed 3 24 24 bits. All right. So since I borrowed 24 bits, that's uh 24. So 24 bits. So then I know that I'm only gonna get one network off of this. And I think you do it I forget now. Is that 2 raised to the 24th? 6. I mean, I think that's wrong. I don't think it's 2 raised to the 24th. That's wrong. Yeah, that's wrong. I forget. Is it 256 minus 2? Don't get me the line. That's not right. Yeah, that's wrong. I can't remember. But the number of bits that's left over are the number of hosts that you're going to have. And the number of bits that you borrow is the number of networks that you can get. That's how that works. So here, I know that I have 8 bits left over. So that's why I was doing the 256 raised to the, 2 to raised to the 8th right here. I know that's hard to see, but that's my number of bits that I had left over. So that gives me the number of hosts that I can have on my network. And then the number of bits borrowed means the number of networks that I have. And I got to forget how to do the actual calculation of that. But here I have I have 16 bits left over. So I will do 2 to the 16th, and that'll be the number of hosts I can get on this network, on the network. But remember, I have 172.17, so I can break this. I can subdivide those hosts up into multiple networks. I hope that made sense. All right, so in here they also start talking about routing tables. Well, let's see if I do IP routes. All right, so in here I have on my box out in GCP, I have a default gateway of 128.0.1, and it tells me it's going out of ETH0. And it also lets me know there is some DHCP protocol turned on here, which makes sense that if I shut this machine down and start this machine back up, I'm gonna send out a broadcast message in order to get a new IP. And that new IP will probably be a private IP and probably a public IP as well too, because I didn't claim to own that IP, the public IP. So inside of AWS, GCP, Azure, you have to uh, uh, own the Elastic IP. You reserve it, so that it doesn't change every time you boot up. And then IPv6. So IPv6, I don't just never played with it. There are some people that play with it and some people that require it. I will have to read through this. I did not read through this in order to set up IPv6. I'm not sure if it's on the exam or not. That's something you will have to read through, but we can go through this. Let's go back to here. Let me see. Do they give us an IPv6 IP address? Yeah, right here. They give you an IPv6 right here. So let's see if we can find a good explanation. IPv6. Let's see. All right. Let's look at this. All right, so they break it down in hexadecimal, of course, and they each one is noted by four. I won't say four arctex, but divided up into fours here. So every fourth it starts a new hexadecimal, and so the zeros can be omitted. Got a need and a list. What I'm trying to figure out, let's see, IPv6 is protocol version 6, which is the IP layer and TCP layer. IPv6 addresses is unique and universal 128 bits or 16 bytes long address space, which is 2 to the 128th, uses four notation to show addresses, dotted decimal notation, colon hexadecimal notation, mixed representation, and CIDR notation. All right, and IPv6 can be unicast, anycast, or multicast. So then they talk about a little disadvantages and advantages of that. What they don't show is how do you calculate IPv6. These are people that are using it. I'm assuming your Alexa is probably using IPv6 as well, but you probably connect up via your IP address, and it may talk over IPv6. Alexa uses 30% of access to their sites. So then they got some benefits there, but they don't show you how to calculate IPv6. So how to calculate IPv6. And I don't think this is on the exam, but just knowledge. All right. Now, help range. Let's see. Okay, IPv6 uses 128 as opposed to 32 bits. We know that part. It's broken up into four groups, giving 8 group blocks that we saw there. Because of the length, various shortening techniques are employed to maintain to omit repetitive zeros. And then they break it up into four. Okay, here it is. The first 64 bits is the network, and the other 64 bits is the node. The other 64 bits are used for routing. So in here, they got the first, I guess, what, 4, 4, 4, 4, 4, and then they break it up into fours, right? So the first 64 bits is broken up, and they use that for network, and then the other 64 bits is used for the node. And then they show you here how to do the different ones: unicast, unique, local, and then they break it down. Like I say, I don't think this is on the exam, but it could be. Like, hey, identify the IPv6 information for this particular node, and then use that somewhere. I'll post this guide inside of the REC study group, but I don't think you're gonna need that. But let's get back to it. Let's look and see. Okay, here they go. They got subnetting here. All right, so they give you an IPv6 address. And because they have 2001 DB8, there should be a 0 in front of there, because remember it's broken up into fours. And then this is 0, 0, 0, 0, and then 0, 0, 1, and then they got an empty octet right there, and then a 1. So they're saying that when you want to break this down, it really looks like this. 48 allocations, 16 for local subnets, and that's how they broke that down. I've never done IPv6 before, but here you go. Here's how they break that down. And your MAC address looks like IPv6 too. All right, so they may do this. Multicast allows one system to send traffic to a special IP address that's received by multiple systems. It differs from broadcast since the specific systems on the network receive the traffic. It differs from broadcast and IPv4 since some multicast traffic might be routed to other subnets. So ping 6, and then I guess a port on ENS3. I'm assuming that is the actual interface. And they're using ping 6 just like ping would be for ping 4 or ping would be for IPv4 traffic. This is for IPv6 traffic. And then they walk through breaking it down, and then they talk about DCP v6. I just don't know when you will use this. I haven't seen anyone use this in real, like every day. I just haven't seen it. It says what number is in size in bits for IPv4? It's 8 bits. Check. Oh, what is it? What number is the size in bits? Oh, in bits for IPv4. What do they want? All the octets? I'm assuming 32 bits. Yep, all the octets. Which term determines how many leading bits in the IP address contributes to its network address. And I'm not sure if they're talking about IPv4 or IPv6, but we'll go with IPv4. What term determines how many leading bits in the IP address contribute to its network IP address. That would be the net mask. I don't think they're talking about the subnet. And then here, which one represent a valid IP address on the host if it's 192.168.1.0/24. In other words, all these bits are turned on, right? So 192.168.1, right? We know that much. What we do know is that we can't have the 255 because it's a broadcast. We can't have 256 because we can only go up to 255. And we do the 256 minus the last node to determine how many hosts that we're going to get on the network. And we know for a fact that this is the network. So by default, the answer is A. All right, it says, what is the number and size in bits of the IPv6? We know that is 128. Right? Did I check that? Yeah, I checked that. It says, now what address does not represent IPv6? All right. So this is, you got to remember 128 bits, right? And each one is divided into 8 fours. No, yeah, 8 fours. So 1, 2, 3, 4, 5, 6. Hold on. 1, 2, 3, 4, 5, 6, 7, 8. Now, the other thing that we have to also look at this, and it has to also represent hexadecimal. And I don't see any hexadecimal here. So I know, so which address does not represent a valid IPv6? So I don't know what that is, but that could be a trick question. It could be this one. Let's see, 1, 2, 3, 4, 5. So that's not true. Is that right? It's supposed to be 8. All right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then this one. It could be all of them if you ask me. What do you all think? I am going to go with this one because I don't know what that is. All right, cool. I'll take that. I figured that was a trick. Any guesses?
I'm just gonna say D.
Hold on for a sec. It may be A. You said, not A. Show solution. This one. Now the question is, why is that does not show a true representation? See, 1, 2, 3, 4, 5, 6. I've seen it like this before. I think I've seen it like this before, but I'm not sure now. That's something y'all may want to read on. Now, which term allows one system to send traffic to a special IP address that is received by multiple systems? So we just got to talking about this. We know it's not subnet, and we know it's not mask, and we also know it's not network. Yep, it's multicast. These right here, the mask and the subnet, those make up what we call a network address or an IP address or what have you. Right? This one I'm not sure about. I have to go through IPv6, so I'll revisit that this weekend and go through IPv6, and then I'll show you my other subnetting way. I just haven't done it in a long time. All right, so let's scroll back up. And let's go here. All right, so the next one is you will have a guided exercise and they walk you through this, where they show you how to use iplink. You'll see that here, right? Where you'll see the different interfaces that you have. You'll see the broadcast, multicast up. You also see the interface. You don't get the IP address though, right? You don't see the IP address, but what you do see is, yeah, it's not showing IP address here. Here they're showing, oh no, in here they're just showing the hexadecimal here, right? So here, locate the network interface associated with this Ethernet address. Record or remember this name and use it to replace ENX placeholder. Okay, yeah. So E takes 0. Here you use IP ADDR. This shows the IP address, right? So I'll give you 2 ways to show an IP address. The old way is ifconfig-a gonna show me everything, or IP ADDR. It's one way, and then the other one is IPA, right? So I'll show it again. ifconfig-a. That's one way. If ifconfig is installed, that there's a bind utils is the package that should be installed that gives you ifconfig. And then IPA gives you your IP address and your interfaces as well. And then IPADDR gives you your interface as well too, right? And IP addresses. So here there's like, well, I want to get statistics on this. So you want to know how fast or how slow a machine is running. So they walk you through getting a summary of packages. But if you're not sure, you could just do man on IP. And then you can, hop down here and look and see like -A gives you that. TCBR, if you want JSON output or -P pre-output, let's do that. Let's do IP let's do IPA P. I can't do P. Do I have to do -P? Let's try. IPA. Can I do IPA -P? Or do I need to do -P? Don't like that either. So let's go in here and find out again. Let's see. I want it to be pretty. I can patch dash pretty, I guess. Do I have to use that in conjunction with something else? I don't think I do. No. Okay. So they didn't like that. Uh, try IP address. Okay. IP ADR dash dash pretty or dash pretty. Probably, maybe. Try dash. Don't like that either. Okay. Let's command on IP ADR. Search for pretty again. Okay. So that's pretty. It doesn't like it. I have to look that up. Find out why it doesn't like it. It may be another switch I need to pass forward. Then here, this ping dash C3 localhost. I'm just gonna ping myself 3 times, but I can do 10 and ping myself 10 times. Here, trace path shows all the hops between the local system and another file. Typically on your AWS or so forth, so on, they don't like for you to do the trace routes and stuff, but take a shot. Let's go. Think. Okay, we'll do that. So they say trace path. Any switches they're passing here? Nope. Okay, trace path. Google.com. Let's see if they'll give it, if it'll go out. Yeah, no reply. It's blocked. No problem. It's probably blocked, and it's probably blocked at the firewall too, right? So you probably have to do something like, do this lab, and in that lab you'll probably be able to run trace route or trace path in this case, in order to find out how many hops does it take for you to get to. That's what you're doing here. How many hops does it take for you to reach that particular workstation or whatever they want you to reach? And so the old command for SS-LT was, wrong one. Used to be netstat dash pant, where I can show you all of the TCP protocols, all network, and the PI, the parent that owns it. But now they have SS. You can do SS dash tuna or SS dash T, and you can do the different. You can do a man page on the different switches. So they got a dash L, probably listening TCP sockets. All right. And then they exit the course on that. That's the lab for that. Let's go back. I mean, they got to exercise. All right, now we get into configuring this stuff from command line, setting up host names and so forth. So let's go to configuring from command line. This probably be the easiest thing you'll ever do, to me. So where everything lists is is in /etc sysconfig network dash scripts. So if you see the old etc sysconfig network dash scripts to ls, oh, we're awesome. Not there. They moved it. Let's see, command line and graphical tools talk to network manager and save files to network dash scripts. This is on my TCP box, so it may be somewhere else. A device is a network connection, blah, blah, blah. All right, so let's go here. Let me find out where they have the network at. Nothing there. All right, ETA0. All right, so let me do a locate. Yum install mlocate. Now I could use find, but I'm a cheat and use mlocate, and then I'll do an update DB. It'll write a file system. It'll write a file that locates all the files on the system, and it'll locate would then use what's located locally. It'll use that file to find me stuff located locally. So varlib, there's at least the DCP client for ETH0, so I don't see everything else. I don't know where it's configured at. So let's continue till we find out. So here on, did we do that one? I don't think I did. Let's try it again. I don't remember if I did or not. Yeah, I did. All right, unmanaged ETA0 connected wired connection one. That's the name of it that they left it as. So now we're gonna do show connections. So list all connections, and then to list only the active ones, you pass it -- active. So that's what they're showing there. So they're showing all. We're gonna show all connections, and then if you do -- active, it's gonna show again. We want to have that one interface on this box. If I connected another interface and made it active, it would show that too. Inside of this configuration, they're gonna show you that. So here they're saying, okay, this is how you add a new configuration. Typically, you should be able to go to etc sysconfig network dash scripts, drop in a file, copy a file right here, like they have here, right? Copy the original file, drop in this file, and then go from there. But here they're saying add the connection name, they're giving it a name, the type of interface, the interface, and then ENO2. That's what that is. So, and that file should be written to here. So let me just do this. And I just want to see if it works. And then let's see if that file is there. All right. So now if I look here, I see that file there. That's the file I was looking for ETA0. So now if I go into this file, you'll see I have my Ethernet type. Do I want to boot off a DHCP? The UUID, the device on boot, meaning if it reboots, it's going to come up at the same time. Do I want to have IPv6 turned on? Do I want to use static or boot protocol or some type of proxy, and so forth? And so that's basically what you did to add a machine. If I went and changed this to ETH0, copied this and made it to ETH0, then I would have a file for my ETH0. All right, so now once you have that, you need to configure it. So they said in the next example, you're gonna create an EN2 connection for the EN2 device with a static IPv4 address. So here, remember first line we did that part, but now let's give it a static IP address, a subnet mask, and a gateway or a route to get out of. That's what they're doing here. And then they say in this example, instead of using IPv4, let's use IPv6. And they give you the 64-bit or /64-bit IPv6 example, and then a gateway, and then also the IPv4 IP address and the gateway. And then whether you want to bring that up or not. So here, connection up and then name. So internet static ENS3, because that's what we named it. And then here, you want to disconnect it, you disconnect it. So now they go through and you can modify some settings. Like in here, we have that file. But now there was like, here's a list of things that you can modify, like how it responds to IPv how it DNS methods, uh, DNS search, what should it be searching for? Example.com, womanlinux.com, whatever. And they walk you through here on how to set the gateway up and so forth, and then how to delete it, modify it, and then all of the commands associated with that. And that's a general overview of this. Let's go back here. Then they have a guided exercise for that. I think, did I just go through that? Oh no, they have a lab, then they walk you through it in the lab, right? And then after they walk you through all that, again, IP routes, right? They had another way to show you IP route, but you can use IP route, right? All right, so all right, so you saw that file. You can edit what takes place. Like, should this be static or none or manual? Should you be using this IP address, which with all the bits turned on, or not, or prefix of 24 or whatever? The gateway set for that, the DNS, the domain, meaning the domain, if you join a domain or you searching or you have a machine up on a particular network, the domain for that, again, IPv6, on boot, the name of the device interface connection, the hardware address. Remember, every Mac card has a unique hardware address around the world. And then they talk about here's what a static looks like, here's what dynamic looks like, or either. And they walk you through that. All right. Then they have another set of guided exercise that's going to walk you through setting up using etc sysconfig network scripts. Using it, this is the way I do it. Whenever I want to make a new interface, I just copy the old file, make a new connection, change the name, and then go through and set the IP addresses up that I want and so forth, and keep it pushing. To me, it's the easiest to do. The only thing that you would have to worry about is if the interface isn't plugged in, right? So changing host name, we've done this before. So host name instance -1, I can type host name instance -2. I can type host name, this instance -2, but inside of etc host name is that instance -1. If I want to change that name for Big Cross Reboots, I can go there and change that in that file. All right. Another way to set it here is the host name, set host name, and then the example. So let's do that. Host name, set host name, instance -2. Oh, what I doing? Oh, host name CTS. My bad. All right, now let's cat etc host name. So what that did, it changed the file. The other way is you can just go change the file. So now if I do a host name CTL status, it'll tell me the new host name that's probably reading from that file. And then like I say, you can get that file. So the other one is what you don't realize uh, is DNS resolution, right? So the way things work is when you're going out and talking to other when you're going out talking to websites and stuff, it's doing a lookup first, right? Maybe cache, maybe in your local host file. But here we have stuff in our local host file for the stuff out on Google Cloud, and it's mapped to an IP address and so forth and so on. But I can put in here another IP address and another host name so I can get to another server. So if I wanted to do that, I can shortcut that without doing a DNS lookup. It'll do a host lookup first and then go out to DNS. Well, also, you can control the order in which that works too. So another one here is they're doing cat Etsy resolve. All right, so the etsyresolve.com, this is where you're telling it what name servers to use and what domains to search. So if I do host name, should be full host name. Let's see, man host name. Let's see, it's a host name dash D. Didn't come up. See, what I wanted to show was the ending, the domain for this particular one, and it looks like it could be the host name us.central one dot dash AC desktop Linux blah 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 or Google dot internal. Another one here is they go back and they show you how you can use in nmcli con mod to update the resolve.conf, or you can just go in there and update it yourself. And then in here they're showing to replace any previous DNS settings with a new IP address list provided a plus or add a plus or a symbol in front of it. So you want to add or minus. The easiest way to me is just going to the actual files and change them themselves. But if you don't want to, you can. If you need to write this in a script, this is what you would use if you had to automate this process. Host classroom.
NM2E?
Huh?
Can you use NM2E?
Yeah, you can. I mean, you can use whatever you want. Me personally, I wouldn't even get into all of that. I would just go in.
On the exam.
Yeah, I wouldn't. You don't have to use that on the exam. You can use whatever you want.
Okay.
So you can go into etc sysconfig, or I mean etc slash host, not host us. And I can go in here and type in 10.1.2.3, and I can say that is new server dot new domain.com. All right, and go there and I can do host. Where did I name that? So now host. Oops. Yeah. Let me see. Host new server dot new domain .com. Oops. They don't have it on there. That's awesome. So buying utils is the actual thing that contains host. This is just another way to do it. It's the old way. Works though. Somebody actually probably has that address, new server dot new domain. That's an IP address. That's coming from somebody. Yeah, that's coming from somebody. Maybe a news server. That's interesting. But yeah, so you can do it that way. You can do the same way with etsyresolve.com. You can come in here and put in a new name server. Say you want your name server to point to 8.8.8.8, which is Google's name server. You can do that. You can do 8.8.4. You can point it to uh, DigitalOcean's name server or something like that, in case you want to. So you can manually change these things. And then in here, that's all the stuff on command line. So the next one is they walk you through changing again host name, CTL status, change the host name, check the status, do the host name at command line. This is only temporary. Doesn't go across reboots. Reboot the system, then they're just trying to show you that the host name didn't stay because it was only at command line. Host the classroom example, modify the Etsy host file, right? See right here where they're going in and modifying the host file. And then ping that host, and then exit. So that's that. They're just showing you the manual way you can do that. And then in here, they just do a review. So what she was talking about was, I think, was it NM2E?
Yeah. TUI, NMTUI.
Just no dash.
No.
Yeah, you can do that too. I don't like doing it this way because I don't need it. So you edit the connection, you use is it the arrows or the tabs? Probably tabs. Let me
Yeah.
control C. Yeah. Escape for me. My screen is messed up. Thank you. I don't know where everything is at because my screen's messed up now. Awesome.
Sorry.
No, I'm just trying to find my screen. I don't know where everything is at right now. I'm going to escape, and then I'll clear, and then I'll run that again. All right, edit wire connection. You can go here and do that. Do you want it to show? You can clone the MAC address there. Looks like that.
No.
What's the escape out here? Q?
We just
Oh, hide.
the address.
Yeah, you gotta hide. Show, enter your stuff. I think this is cumbersome myself, but if you need a visual, yeah,
It's really easy.
I think it's cumbersome. I'm gonna tell you why I think it's cumbersome. Let me show you why. I get it. I get why they did this, but I think it's cumbersome. All right, I'm gonna tell you why I think it's cumbersome. So if I want to add a new interface, right, I'm just gonna do this. Then I come in here, I'll change this name to ENO3, right? I'll change this to 3. I'm going to delete this UUID and leave everything else the same, and I'm done. If I want a static IP for that, I come in here and change this to, I can change this to static. If I want to define an IP address, I'll do IP ADDR equal to 121212, whatever. And then it's a prefix, it's all caps, and I'll say /24 and whatever the subnet is, and I'm done. I don't need to do nothing else. That's why I say I think this is just easy. I think all the other stuff is nice to have for people that like to roll through there. I just think it's easier to change it from command line.
I just don't want to. I hate this file. Like, I hate changing stuff in that file because I feel like I'll make mistakes there.
You can't make mistakes if you follow the process,
True.
right? And the process is if I know that I gotta change something in this file, I copy ifcfg eno to ifcfg eno to .org. So now if I go mess with this file and I screw it up, cool. I can get back to what the original file was. That's why I say anytime you make change, you know you're gonna make changes to something, save it first, then change it.
Right.
That way you don't have a problem. Here it says configure the host file so that 1.0.1.1 can be referenced as private. Echo. That all they're doing is changing the file. It's real simple there. Modify the new connection so that it uses the IP address of this. They probably use NM for that, or you can go into the file itself and change that. That's what they're showing you there. Configure the new connection to be auto started. Other connections should be not started automatically. You can go into each one of those files and turn off the boot process to was it on boot to be no?
On boot, yeah.
Yep.
Oh no.
Yep. And in here, they're just showing like IP link and then NM to IF name. This is a manual add, but you can also go in and create a file, copy a file that you have there, and then add to that file. Reboot the system. There you go. From workstation, use ping to verify that server B is initialized ping and whatever server B is, right? And then review. And then the next one is a summary. Chapter 13, we transferred files. I went over that already. It's in another one. Let me go to the summary here. Lab, no quiz. All right. 14, install and upgrade packages. I went over that already with yum install, yum remove, RPM. What's the difference between yum and RPM? How do you enable repositories? See, explaining and investigating RPM packages. Here, the Q and the P, you can find out what those are by doing a man on RPM. And the -I, the -L, -- scripts. I've been showing you those things. CPO, they talk about RPM to CPO. Usually back in the day, CPO was used to archive tapes. It really comes from tapes. CPIO comes from archiving and reading tapes. See, they get into, archiving. Right here, there looks like, let's see, extract all the files, use RPM, CPIO, and CPIO to extract the files and create deleting directories where needed in verbose. I never had to use RPM to CPIO. Not saying that you can't use it, I just never had to use it. All right. Let's see. Installing and updating Yum list, Yum search, Yum info, Yum provides, and Yum what provides. So if you see a file there, you can say Yum provides, and they say to find the package that provides this, you can do Yum provides, and then it'll go through the actual history of Yum, or I should say the database, and tell you what package that comes from. That's the repo that it comes out of, and it'll tell you the package that was used to install that HTML particular file. Install HTTPD Yum update, so you can update Yum or you can update a package. You can get a list of kernels. There's a difference between uname-r and uname-a. Uname-r meaning it gives you the version of the kernel. Uname-a gives you every single thing. There are other parameters with uname as well too. How to remove a package, the different groups that are installed. So you can use the double quotes to install a group. Here you're just getting group info, or you can use the @ symbol to install with a group. But here's just a simple way to install a group of packages. So if you want to install all the packages that are centered around server GUI, you can install that. Or if you don't know what's in server GUI, use Yum group info to find that out. And then they have what they call install and remove transactions. DNF comes from Fedora. This is upstream. They're starting to introduce DNF inside of Red Hat, which tells me that they're probably going to start switching over from Yum to DNF as a package manager installer. But Fedora is upstream. I want to say Ubuntu probably uses it as well, maybe. Yum history. So Yum history, it tells you, gives you a usage of what you did. Like, hey, you installed some package, you remove package. Here's the date. So you can do a Yum history undo 5. So go here and remove HTTPD. You installed HTTPD and some 9 packages were associated with that. Go ahead and remove those. So this is the advantage of using Yum over RPM. Yum resolves dependencies, RPM doesn't. And it keeps a database of what was installed. You don't have an RPM history. All right. And then they break down each one of these, the command and the options, what they give you. All right. Let's go on to the next thing. They just go through and have a lab for you to go through for that. I won't spend no time there. Repositories. So so you can configure repositories this way. Yum configure, or you can go to cd etc yum.repos.d and look here. If I want to add a repo, I can just copy RH Cloud repo to new .repo, and then do new .repo, and then come in here. If I want to edit, if I want to copy and edit, at least I have a working starting point of what needs to be in here or what can be in here. Remember, mostly everything is optional except for what needs to be in brackets, the name, and it doesn't necessarily need to be mirrorless. It may be base URL, and if it's enabled. You don't have to enable GPG check and all the rest of this stuff here. Just knowing what you need to do, the base minimum, in order to get things started. On the exam, they'll have you set up a local repo because you'll probably be copying a CD or something like that on the exam to make a repo. You can use Yum Config Manager to enable. So right here is updating subscription right here. It's adding that repo enabled, and it shows you what it does. So here, the base URL, the cache, the cost, the delta, and this if it's enabled. And so that's what Yum Config Manager is doing there, right? creating Yum repository. So here is you're adding this repo here, and 9 times out of 10, it should be creating a file for you. Yeah, to show that the name, the base URL, and it is enabled. So let's copy this, right? And let's add it here. Let's do ls. I'll remove new repo. I'll clear. Oops. It didn't like me because of that copy there. All right, and now if I do ls, you can see I have a repo named DL Fedora project or pub EPL 8 everything x8664.repo. Please don't do that on the exam. Just make it short and simple. EPL 8 everything dot repo. You don't need to specify 64-bit. No one makes 32-bit anymore. All right. And so if you go into that file, or if you cat that file, you can see that it did the name, the base URL, and it's enabled. And if I do a Yum repo list, you can probably find this. Let me scroll up here. Right here. Created the repo right here. It's there. It's at the top. So the repo is listed there. And to tell you who it was configured by Yum config manager. So we know that worked. All right. Then the other way you could do that is you could just make it EPEL, the name, the base URL, enable GPG check and GPG key file where to pull that from, and then you throw that into a file called EPL.repo, and that's your file. That's your repo has now been updated. And you do a Yum repo list to make sure that it can read that file. That's why I do a Yum repo list, to make sure it can read. So in here, we're importing the GPG key. There's a GPG key for all Red Hat packages as well. And you can see here, it's going to look for that key inside of here. It gets imported and it looks for that key here. Each one of these look for that key. And they talk about that. Next up, enabling Yum repositories. Again, you can configure it manually, or you can use the commands in order to do it. I do it manually. Been doing it, works for me. You don't have to do it that way. You can use the commands. They come in handy sometimes. All right, module streams. All right, so this is new. Application introduction to application streams. So in 8, they say introduces the concept of application stream. The multiple versions of user space components shipped with the distribution are now delivered at the same time. They may be updated more frequently than the core operating system packages. This provides you with greater flexibility to your RHEL system without impacting the underlying stability of the platform. So they have what they call base OS and then application stream. Both base OS and application stream are a necessary part of the RHEL 8 system. And then in here, they talk about the application stream repository contains 2 types, the modules and the traditional RPMs, right? So the modules describe a set of RPM packets that belong together. Modules can contain several streams to make up multiple versions of applications. So they walk through and talk about module streams and module profiles, listing modules. So let's try this. Yum list module. Oh, did I do module list? Might have had it wrong. Yeah. So you see it's reading the Fedora and then it's gonna read everything else. All right. So display a list of modules. Go here. Use the hint at the end of the output to determine which streams and profiles are enabled, disabled, as well as which ones are defaults. All right, so let's go back and see what we got here. All right. All right, so E for enabled, D for default, X for disabled, and I for installed. So let's run this again. I don't like that output. All right, a little better. All right, so they walk through and show you what's going on here. Container tools, and you can see the D is there, and they said that the D stood for disabled. Right, so disabled. You see a lot of things disabled, right? All right, so that's that. Then it says to display to see what's going on with Pearl. It's disabled. If we list that module to display details about the module, we do the info just like you did with Yum info, Yum module info, that Pearl module. So now it says without specifying the module string, here you can show the list of packages installed by the profile module. And here they want to do like the module name :stream. I'm assuming :stream, and maybe the actual version of the stream, right? Because I think you can have multiple versions here. Because you got multiple packages, right? Multiple applications would have multiple versions. And so then they show you that part, and then enabling streams and modules. So you're gonna install it. Only one module stream may be enabled for a given module. Enabling an additional module stream was disable the original module stream. So I guess this installs the latest, but if you wanted that 524, you would go back up here and do the info, and then probably specify that particular version. List. And then they talk about this right here. I would do a deep dive on reading into that. And then remove Pearl, the module, the list, disable it, and then switch your module strings. Okay, so here we have module info Postgres grep module 8. So let me see. They're doing a sed dot star colon and replace it with nothing. Right? That's replacing it with nothing. XR yum list initiated. I mean installed, initiated. And then they remove. So the list of packages installed from the module in the example below, Postgres 9.6. Remove the packages listed from the previous command, mark the module profiles to be uninstalled. They're removed. And then after removing the modules, reset the module string. And then they reset. You may want to look up what reset actually does. Does that mean that is you removed it and you disabled it? Let's look up that. Redirecting DNF command reference, but let's do reset. Reset the module state so it no longer is enabled or disabled. Consensually, all installed profiles will be removed and only RPMs from the default string will be available in the package set. So that's how you look that up find out why am I running a reset? What's the significance there? And then go back and do another one, a module C, specifying a particular string. That's why I thought you just do the :10, right? If I wanted to specify a particular one. And then they'll walk you through a guided exercise for this. And then here's a lab. All right. I won't go through these. I'll let you walk through this. And then 15, accessing the Linux file system. I'll say this for tomorrow. And I'll do the subnetting over again. So you all can get the subnetting so you don't have to and stuff. So you can figure that out. And then 16, we'll do 15, 16 and subnetting tomorrow. And 17 is just a summary of everything. Next week, we'll go through it and summarize everything. I've already started making a quiz already to go through each one of these chapters. I need to finish it though. But 15 and 16, we'll go over that tomorrow. And 17 will be next week. So next week will be a review of every single thing. For those 2 days. I think we'll be able to knock out 15 and 16 tomorrow. I won't go in order next week. I'm just gonna pick random things, random topics here, and then we're gonna run through it. Right? Like I should be able to ask you next week, what is the TCP IP stack? Right? What is the OSI model? Right? And not that you need to know it for the exam, you just need to know it, period, when you're in conversation for interviews, because people are going to ask you that. What's the difference between TCP and UDP? How do you communicate with SSH? What port does DHCP run on? How does DHCP talk? If I use TCP dump at the command line to grab to grab TCP packages on ETH0, how would I do that? I won't ask you that, but people will ask you that in the interview. So understanding what TCP is and what UDP is one thing. How do I resolve a host name, right, in Linux? How do I set it up to, I set the host file up /etc host to resolve womeninlinux.org at IP address 192.168.5. But when I do a host womeninlinux.org, it's returning .241. Why? What happened? Where's that set at? Was it pointing to the wrong DNS server? How would you troubleshoot that? Those are the kind of questions you have to ask yourself or answer to yourself, because that's how you troubleshoot when you're on the exam. How do you get yourself unstuck, right? So thinking of different scenarios that will cause you to get stuck, and how do you use these commands to unstick yourself? That's where that comes from.